Okay, so this is my this is me starting to work on this project where I'm taking footage from a 360-degree action camera. So this is footage in 360 degrees. My goal is to create a web app where first the video is sent to the cloud, then faces are identified and presented to the user. The user selects a face, and then we generate a video which is cropped, which shows the person in the video moving. That is my goal. The way I plan to accomplish this is I'm first developing the algorithm using Google Colab. And once that's done, I plan to use queues, workers, and S3 along with probably a little DynamoDB in order to basically host this on AWS. And my intended artifacts from this are a system diagram, a system walkthrough, and a product walkthrough. Ideally, if I have bandwidth, I'd like to make a cloud formation to stand this up. I'm going to show you what I accomplished today. At a high level, what I accomplished today was I went from raw video. This is the raw video. And this is me with my little bit of muscle. Okay. Well, you know what? I want to talk about myself nicer. This is me with my pretty awesome shoulders and a boom, a boom, a boom. I kind of go back and forth a few times. And this is me just doing a very simple test of the capabilities of this camera. Here's the final result. So the goal of this was to determine where the face was frame by frame. Here's what we see. As you can see, when you cross the seam, we lose the face. That is one big challenge. Another challenge is in general, like bear there, a face can be lost as well at random, a little bit randomly. So my goal is to handle situations like that. But this is what I have right now. This is very naive, and this is implemented using right now, what we do is we grab the face and we use insight face in order to detect faces in the image. I believe we do this every frame. We should do we do it every frame or every 10 frame? Let's take a look. Okay, it's every 10 frames. And we create this box and store it, and then we do our thing. Actually, this might be oh, this is, okay. This is some new code that I didn't finish. So step one was the outcome that you saw. Same algorithm where we just run the facial detection on every single frame and every single scan, and we present that to the user. Step two, I'm going to do this every 10 frames and take a look at that result. Step three, I'm going to use a Kalman filter and I'm going to have it run its prediction, but I'm always going to have it use the measurement unless there is no measurement, in which case I'll have it use the predicted. And what I'll do is I'll look to do this between the first and last frame that we have a face, and I'll use it to interpolate in between. That is the goal of my filter. Of course, I could always use some other type of filter. I think a Kalman is fine, and I'm just going to use a Kalman in the spherical coordinate space. Let's write this down just to make it clear. So what I showed you is every frame face detection result. Then I have every 10 frame face detection result. Comment on vehicle coordinates, improve facial. So cube map is me taking the spherical projection and converting it into like these squares of perspective. And then from those squares, having a much simpler time in connecting, it will connect the seams together so that we don't lose a face. That is what it does. It does still have some discontinuities. That is something interesting to consider. I was more tempted to do reflection, but that cube thing just sounds more interesting to give a shot. So I'm gonna give that a try. Uh, yeah. Then regardless, the common filtering is gonna happen in the spherical coordinate space. That will make it really easy for things to wrap around. And we'll be going from there. So thank you.